look at this whole issue of cybersecurity. So what we're going to do, by the way, my name is Johanna Zmud. I'm a senior research scientist here with TTI, and I reside typically in TTI's Washington, D.C. office. So let me start. I'm going to introduce our 4 speakers at the beginning, and then we'll go into the presentations. They're each going to speak for about anywhere from 10 to 15 minutes, just to give their perspective on important issues. And then we really want to open it up to Q&A, because we really see this as a information gathering, knowledge exchanging, and sort of looking at what the options are and alternatives are. As I'm going to wait for some people to come in. Okay, so as I mentioned, 4 speakers. Our first speaker is Michael Denning, who's with the Volpe, USDOT's Volpe National Transportation Systems Center. And Mike leads cross-cutting initiatives at the Volpe Center, such as cybersecurity and resilience, which is what he's talking about today, multimodal payments and mobility in smart cities, and transportation data analytics. Mike is the chair of the Transportation Research Board's Cybersecurity Subcommittee and a member of TRB's Transformational Technology Task Force. Following Mike, we have Doug Kuto, and Doug is the former Chief Information Officer of Michigan Department of Transportation and the state of Iowa. He's the past chair of TRB's Information Systems and Technology Committee, and he's currently a senior fellow at the Center for Digital Government, focused on technology innovations in transportation and smart cities. Following Doug, we will have Steve Cambone. And Steve was the first Undersecretary of Defense for Intelligence. And earlier in his career, he was the Director of Research at the Institute for National Security Studies at the National Defense University, a senior fellow at the Center for Strategic and International Studies, and a member of the Director's staff at the Los Alamos National Laboratory. Steve is currently our Vice Chancellor of Cybersecurity Initiatives at Texas A&M University. And then last, but Steve certainly not least, we have Steve Dillon, who's with Southwest Research Institute. And Steve, let me get that paper, here we go. Steve is the director of the Intelligent Systems Department. He is leading Southwest Research Institute's efforts in intelligent vehicles, where they have performed over 40 million of R&D in the areas of connected vehicle and autonomous vehicle and active safety technologies for commercial, state, government, and military clients. Southwest Research Institute has fielded 8 different autonomous vehicle platforms with assorted enabling technologies, and he's going to be going into some of that for us today. So with those introductions, I'm going to turn it over to Mike Denning from Volpe.
Thanks, Johanna. They asked us to speak from the mics or with a mic, so that because they're actually streaming this to YouTube somehow. So this is kind of exciting. We don't do that with cybersecurity events very often, so this is a biggie. Just to get an idea for us where all of you are coming from, how many of you are involved in cybersecurity? Okay, we've got a lot of ringers in the audience, so that'll be great because you guys are going to answer all the questions at the end. But really, the interest and the questions and perspective that all of you have is really important. Future research. I just came out of the Transformational Technology Task Force of TRB, and they're counting on you to raise some of the issues, the key issues in cybersecurity and resilience. So it's really, think of it, you're not only making a comment for this session, but you may be steering some really important efforts in the future. As you see in the title I've got here, I'm looking at this as not only protecting our transportation systems from cyber disruptions or attacks, but making them resilient. Because we know we can't protect against everything, We're really trying to minimize any kind of disruption, whether it's a deliberate attack or any other kind of failure. So the idea of cyber resilience is something a lot of us are talking about a lot more. Most of you are probably aware that virtually every part of transportation, our vehicles and our infrastructure, are getting really well connected with each other and with our infrastructure and with other sectors like the energy sector, telecommunications. So with that increasing automation we've been talking about all day and this connectivity, the potential for cyber vulnerabilities and risk is increasing. And in fact, it's real in many cases. Now, many of you are going to see the image I'm going to show next. It's probably the most infamous image of the implications of connected vehicles on cybersecurity, because this is a connected vehicle that two white hat hackers, Charlie Miller and Chris Velasek, took control of 3 years ago and actually controlled it off the road. They exploited a vulnerability in the cellular connection with that car. So it just showed this connected vehicles have lots of benefits, but they're potential vulnerabilities and risks. Not only did this get a lot of attention in cybersecurity in the industry, in transportation and other industries, but it resulted in 1.4 million of the Jeeps being recalled. And they didn't physically take them in. They brought in sent the owners a little USB stick to upgrade their software on the cellular connection. Unfortunately, not every threat to transportation is as well-meaning as Charlie and Chris were. They were trying to help show vulnerabilities so that the component suppliers and the manufacturers could make improvements. But some of the threats on transportation are real, and they're really serious. We've had increasing criminal attacks. People have used transportation for smuggling drugs with cyber attacks facilitating that. We've got ransomware attacks like the one on San Francisco Metro last November. We've got hacktivists like Anonymous shutting down some of our transportation systems like they did at BART a couple of years ago. And that was actually a hybrid attack where they were doing a physical demonstration to disrupt the service, and at the same time Anonymous came in and did a cyber attack. And then finally we've got nation states. Many of you are probably aware that North Korea has been jamming the GPS around South Korea for many years, and it's been so serious that South Korea is setting up an alternative navigation system using eLORAN technology. So we've got some really serious threats, and the big question for all of us here in this conference is, with connected vehicles and automated vehicles coming, is that going to increase the vulnerabilities and risks even more? Or do we have a chance to bake it in, to build it in and treat things, consider things now from the beginning so that we may actually come out ahead on risk compared to where we are now? So when we've been planning for this session, we had a lot of questions. How do we manage, well, actually, what are the threats and risks to connected vehicles and automated vehicles? And particularly, what is that when you integrate all this with all the Internet of Things in a smart city? We're interacting with power systems and communication systems and some things that the transportation community doesn't even control. What can we do to protect that and make it more resilient? And how can the private and public sectors work together? And as I said, we need your ideas about what research is really needed for the future. And in planning this, talking about potential issues, one of our panelists, I won't say who it was, but somebody even said, do we need more regulation at the federal, state, or local levels? That's a hot issue. So we're going to get right into this. Doug's going to go first, and Doug has a really interesting perspective as a former CIO from state agency and as one of the key experts that's working with the Center for Digital Government. And Doug, many of you may have seen Doug in ITS World Congresses. He's organized sessions on this topic literally all over the world. So Doug, it's all yours.
Thank you, Mike. With a lead-in like that, I don't know what else to say. Except with the intelligence guy from the Defense Department here, the other job I had was the Director of Information Management for the Air Force Intelligence Agency down the road here. So I am coming back to Texas. It is a little bit of a homecoming. Mike, how do we switch this? Yeah, but I can't see this, the font. There we go. So what I'd like to spend a few minutes with you this afternoon is talking about some of the things that I see happening at the state and local government side, some of the emphasis, some of the disconnects, and maybe as part of our discussion, what are the opportunities for the transportation component of a smart city to work with a city that is going digital everywhere with everything and building infrastructure as well. We do a little bit of work with the private sector. We also survey the state, local governments about where they're spending money. Some of the private companies may have used our Navigator product, which projects the RFPs that are coming out in the coming year, but with that it creates some data, and that's where we get some of the numbers and talk about what the industry is doing. These are some of the numbers for the transportation infrastructure. $320 billion on transportation infrastructure in 2014. Most of it is really maintained and managed at the local government level. And I think that's an important point to keep in mind. Our estimated technology spend for state and local government is $101 billion. And these are some of the issues with related to transportation. We think there's, just for IT portion, just the IT portion, that the spend for 2017 is going to be about $10.3 billion across the local government arena. And that there are a number of things that are driving that. Aging infrastructure, the need to maintain things, just basic replacement costs. The IT opportunities in local government, everybody's going smart. Smart meters. The city of New York is tracking trees. We've got technologies going in that are planning trash pickup. Sensors are going into trash cans. And when it compresses it, when it fills up, it sends a signal to the Public Works Department, and then they build the pickup for that day based on the trash cans that are full, rather than driving around the city every Monday and doing one segment at a time. It's more efficient, and if you happen to be a large trash generator, you get your trash picked up more frequently. And if, like my household, it doesn't have a lot of people in it, you can come every 3 weeks and it wouldn't make any difference. It may still not be full. A lot of real-time analysis. See a lot of modernization of applications. And then, of course, we're all working the ITS side. We surveyed CIOs at all these levels, and I just wanted to share something with you because I think it's gotten lost in the conversation. These are their top 10 priorities. But if you look at state CIOs from 2012, 2014, and 2016, and I think this will hold in 2017, cybersecurity and shared services were the top two. Cybersecurity became their number one issue, though, in 2014, and has stayed there. Shared services is really becoming more efficient with our systems, building data centers that people share. The city of El Paso does a GIS system and then makes that available to all the neighboring communities so that they're all integrated. So that's a shared service. The city at Denver is partnered with fire protection so that if you have a fire and you're near the border, the closest fire equipment is dispatched, and then the jurisdiction that's responsible for that particular area then takes command. So those are the kind of shared service things that we see developing. When I go to counties and to cities, cybersecurity last year was their number one issue as well. And I wanted to share that with you because as transportation people looking at connected and automated vehicles, I don't see this making the top 10 list until people like Steve and I and Mike have started to raise these issues in the ITS community, at the TRB, and now we see the executive boards and the DOT executives beginning to say, well, maybe there's something here we need to be concerned about. And I'm looking at one right there, he's smiling back. So some of the local trends, and I just want to spend a second on this. The growth in shared services and collaboration is occurring in all kinds of segments and operations within our communities. I do see at the city, when they're talking about integrating with transportation, some focus on what we know as smart corridors, but not the full integration of the rest of the transportation services. Public transit tends to be a whole separate entity, separate board of directors, separate CEO. Tolling authorities tend to be separate entities with separate board of directors. And they use the same technologies and have some of the same issues, but they're not fully integrated in the dialogue and the management of the region. I'm seeing a growth of public-private partnerships and cooperative arrangements between communities. The innovation is phenomenal, and it occurs in all kinds of spaces, in all kinds of ways. One that struck me that I looked at last year, one of our communities decided they were going to train people to do CPR, which is pretty important, right? If you're having an event, having somebody next to you that knows CPR could make the difference between life and death. So then they created an application, so all the people that were trained were tracked and they're mapped. They know where they are in the city when they're turned on. So if somebody suffers an attack, the first thing that happens is they see if there's anybody nearby and they ask them if they're willing to respond. So that immediate help may be available. More often than not, it is. At the same time, then they're dispatching the ambulance. And the ambulance is to get there, has got to get through traffic signals, make sure there's not a road closed for construction or congestion or whatever the issue is, and then get back to the hospital. So, is that a health issue? Is that a fire issue? Is that a transportation issue? And I would submit to you, it's all of those, and the only way for that to work in the community is for us to work together. And that all falls apart because everything I just described to you uses a network, uses applications, and is vulnerable in the cyber area. There are a number of things that local governments are doing to protect themselves from in the cyber arena. One of the biggest risks are people. So I'm seeing money spent in the last couple of years on training people to be smarter about how they do things, like changing passwords and not writing them down, and those sort of things. But you know, I just recently acquired a Ford truck, and with it came a maintenance plan. So I went to the dealer, and I said, do I need to keep this maintenance plan? Came with the truck, didn't cost me anything. I thought I would anyway. But he said to me, you know, there's 32 computers in that vehicle. And he was trying to convince me to do that maintenance because if one of those 32 computers broke, there were technical issues. And I decided to keep it because any virus or penetration of any one of those computers, like the Chrysler, would put my whole vehicle at risk. And the risk would be taking it to the dealership and hooking it up to their diagnostic equipment and having something inserted. I learned that lesson back in 1990. We had a young airman who had to get a report out. It was over Thanksgiving weekend, and he went to the local office supply store and he brought a spreadsheet. Now, we didn't have the sophisticated tools back then that we have today. He had it on a floppy disk. He brought it in, inserted it into his machine that was network connected, and it had a virus on it. It cost us millions of dollars to clean up that system because somebody tried to do the right thing. In our investigation, we found that a disgruntled employee at the company had put the virus on as he was being fired. So that risk is very real today. Yep, 5 minutes, I got it. So that risk is very real to us today. I'm seeing more tools, the NIST tools, the assessments being done to look at city. We're starting to see an adoption of what's called security as a service, where tools are being provided by a third party from as a cloud. One that we haven't talked about in our world, but I see local governments who are concerned about risk, they're buying cyber insurance. They're using assessments to create strategies. And I think the more advanced communities, Mike, I'm also seeing cybersecurity being now included in discussions on the community's resilience plans, emergency management. So it's not just the rest of the utilities, but can we keep our critical systems operating? There's a lot of organizational changes that are occurring. One that I have seen is a separation of traditional CIO roles from the commodity providing areas. TxDOT here has outsourced their IT organization to a private company, but it's the commodities. It's maintaining the servers, the network, the applications. They've kept the critical stuff internal, the database, the information, who has access to it, and how that can contribute to operations and innovation. So you just have to decide where you want to spend your money. That is occurring, though, in other DOTs in different ways. A chief technology officer is taking care of the commodities, and the CIO is now becoming more data and information focused. The Virginia DOT took their CIO and made him the IT strategy planner. This is a slide from Mike Leonard on the connected cities, autonomous automated vehicles, the smart city technology. That all comes together to improve our community. I wanted to put this slide up because what's missing from it? The bottom line in my mind should be a foundation of cyber and resilience, because all this totally falls apart if it's hacked and taken down. And the reason I'm concerned about that is this slide. In our own surveys, we asked the cyber people, the IT folks of our communities, what kind of dialogue are they having about autonomous vehicles? 23% said they had some dialogue with the transportation folks. 33% said they had none at all, or 42% said they had none at all. In the green, 33% said they didn't know. So if they didn't know, it means they didn't have it. Nobody's thinking about it. Some of the common cyber risks that are occurring, where we're sharing admin systems. If somebody's infected, everybody's infected, particularly billing systems, payroll systems, all those sort of things. Shared networks and servers as we consolidate organizational barriers because people aren't talking. As we've let private sector folks into systems to do maintenance, that creates another risk. and just the bad actors. And Mike, I think, did a good job at talking about the world. I came out, I live in the state of Michigan. The state gets 800,000 attempts to break our systems every day. Every day. And only one needs to get through. Only one needs to get through. And you take out the Secretary of State driver's license system. You know, as a DOT CIO, I used to say, well, we're not concerned because we don't have any things that are real crucial. So what if they steal some of our stuff? You know, it's all published and available to the public. But today the goal is not to steal the data, it's to disrupt our way of life. And if I can take something down and steal it from a DOT, make it hard for them to do business, like the San Francisco transit system, I've accomplished my goal. And we've already talked about those. So the number one thought I'd like to leave with you today is security concerns will continue to influence everything we do. Smart is changing. Connected automated vehicles are changing the way we should look at things. But what I'd like to have happen out of our dialogue is what are the opportunities for partnering with these other organizational entities that are investing in security as well to benefit both transportation and the rest of the community. And I've got a few questions for us to think about in terms of future research. And with that, Mike will be our next speaker.
Good afternoon, everyone. I'm Steve Cambone, and I am one of the new guys around. Almost as new as you, but and just for the record, I am an associate vice chancellor, not the vice chancellor. She's my boss. Thank you. I appreciate it. And I'm always happy to do it, but I didn't want to leave anybody with any misperceptions. I was fortunate enough to hear the luncheon address today, and I thought it was spot on with respect to the potential implications of the environment that we are moving into as a consequence of the evolution of technologies, particularly in the ICT environment. Now, I'm not quite as certain as the representative from Lyft that we all have surrendered our individual automobiles to the common good, but she's close to, I think, beginning to frame the kinds of issues that are going to arise for each and every one of us. And I was coming into this conference trying to think about an analogy that might be useful, and let me try this on you. The autonomous vehicle 2020-2025 is to the world moving forward from that point what the Model T was in the early 20th century to where we are today. Right, so that 110-year cycle is now coming to an end, and some of the critique inherent in her presentation, particularly about the cityscapes and how they're organized and the parking lots and all that, that's all a consequence of the arrival of the Model T and how it took over our lives and those of previous generations. Now, having said that, these two things are fundamentally different in their effects. And it may be partly the time that they arrived, or will arrive and had arrived, but the Model T represented an opportunity to break out of communities. It enabled individual activities. It made it possible for you to go anywhere, do anything you wanted to do, and you could probably, until you got into the 50s, 60s, 70s, find some place to go as fast as your Camaro, just to sort of start to, go back to the songs that she was talking about, would take you. And there isn't a beach boy alive today who would be having anything to do with Lyft or Uber or any of those guys, right? Because, what's a Woody? I mean, come on, that's not. But there is going to be a cultural change that's going to take place as a result of the kinds of things that she was talking about, and I mentioned the issue of regulation. I'm not for regulation, but I'm here to tell you that those automobiles are going to bring, that transportation system is going to bring with it a plethora of regulations that we can't even begin as we sit here today to imagine. And so if there is a research agenda to be had, it is to begin thinking forward about what those regulations will be. And they will be in the place, in the areas that you would think they would have to be in if you're going to live in an environment where individual human beings are not controlling the environment in which they are living and operating. And so it's going, those regulations are going to have to affect things like what? Speed, right? How fast to go is going to have to be regulated. Access, when you can go someplace, where you can go. And we have sort of that today. You got the congestion tax in downtown London, right? So unless you're willing to pay 60 pounds or something, you can't bring your car into a certain area downtown London. There are other cities here in the United States that are the same way. But when it's done electronically, right, it's going to be a different experience, let us say, between and amongst ourselves. Now, it may be that you're in a communal vehicle, your access will be different than if you're in your own vehicle, right? So that's the kind of regulatory environment we can look to. The kinds of uses that you can put it to. And again, her commentary this morning began to allude to the way in which the use patterns of automobiles could change as a result of autonomous vehicles. And then, of course, the ownership issue. And with the ownership issue, of course, comes control. Right? And I noted at one point, she said, one of the points of the business model is that those who are supplying the service control it. Very much like the garbage trucks, right? Because that's the only way that's efficiently done is if that control is centralized over. So but my point about all this is that it is going to yield regulation, and that regulation is going to be rooted in data. And it's going to be data about the performance of those vehicles, about the uses that we put those vehicles to, and who is using them and how they're using them and when they're using them. And what that's going to lead to, I suspect, is you then start to think past regulation and start thinking about infrastructure. Today we pay for most of that transportation infrastructure through gas taxes. In principle, that gas tax will begin to evaporate. It already has begun to decline in terms of the amount of revenue it brings into the system. So there will have to be a new taxing mechanism found to sustain the infrastructure that will go into providing for the performance of those vehicles. And that tax base is going to have to be generated on the same data. So notice I keep coming back to the same thing. This is going to be about data. And it's going to be such that that automobile or that conveyance is going to be for people in 2030 what our living room environments or office environments are today. We will function in those spaces as we do in other spaces, and therefore we will be generating a plethora of additional personal data which will be collected. And that collection will be done both by the government for the purposes of making certain that it's able to tax you on your uses and all those other kinds of things. But you're certainly going to see, as Uber has just tried to do, right, the resale of that information to others who are going to market to you while you're in those cars. Now, as it turns out, all that data goes into a system in the back end, and in that back end world, many of those applications that you have separately on your phone are actually talking to one another in the background in order to be able to service your needs. So there's a reason why Waze can tell you where the traffic accident is, and then the app comes up and tells you to go to this store and buy some groceries, right? I mean, there's a relationship between those things that is taking place in the background that's unknown to you. Now, from all of that data, your life is an open book. And so the reason for the cybersecurity, apart from the operation of the system, but to guard your own privacy and, in fact, your freedom of activity, is going to be in protecting the generation of that data, the transmission of that data, the storage of it, and then the manipulation of it, and then the downward flow. And that is a monumental amount of data that is going to get generated. If we think that the Ford Fusion today is 32 computers, right, and that's mostly for the diagnostics of the car and to do the updates and tell you when to do your servicing and whatnot. In the future, it's going to be not only that, but it's also going to be your activity, where you've been, how you got there, who you were with, how long you spent there, when you left, when you came back. All of that is going to be collected. So when we think about the cybersecurity issues, we have to start with that fundamental change in the fact of life and the way we are going to have to live it. Now, is there regulation that is going to manage that part of it? I don't think so. And the reason I don't think so is I'm not sure that regulation can keep up with the rate at which the data will be generated and new and different ways will be found to apply that data for all the various purposes that many of us will find congenial, by the way. But the regulatory environment will have a very, very difficult time catching up to that. So that suggests, to me at least, that as we think about the communal environment, or the more community-oriented focus that will be potentially generated as a result of autonomy in vehicles, there may be another strand which is going to begin to focus back on individuals and how they are going to be able to assure themselves that what's important to them is protected in some way, or at the very least, that they are immediately made aware of when that information has been breached and has been extracted and certainly is being used by parties who are not authorized by those individuals to do it. So, all right?
Walking up on a milk carton. Shutting down. There's a message. That is a clear message to me. Okay. Well, I will, while the computer's booting, so I come from an organization and maybe a view that's a little bit different, but I think complementary to what Doug and Steve and Mike have talked about. I work at a research and development company, and we're about 3,000 people. We don't have a single product line, but we do R&D projects. And in the area of, hang on, it's asking me, who should I log in as? I have choice of user, admin, or administrator. So I'm coming at this from a perspective of how do you break things. And I'm going to come a little more engineering level and hopefully give you a little lower level look at this. Our organization, I've got a group of about 12 cybersecurity people. How many people have ever met a cybersecurity kid, someone under 30 that does cybersecurity? They're weird, aren't they? They're clearly the most interesting, most challenged engineers we have on campus. Typically strange work habits, lots of different aspects of them. They love to break things. And so we have companies bring us products before public release, and they ask us to break them and to hack them. So there's always this contest, how long will it take us to hack it? I'm wasting a few minutes here until he starts this. We just released a new corporate website, and the cool thing was it took our guys 14 minutes to hack our own website. And our department they were absolutely thrilled about that when they heard that occurred. So, see if we can get in here. So, you know, oftentimes the dialogue you hear about cybersecurity, I think people are thinking more about malware or phishing attacks. You know, they click on a link, and you know, people that pass laws or donate money or give money to fund projects, they don't understand the level of cybersecurity that's real in the CAV community. They're thinking this high level, oh, I got a phishing attack, you know, some guy from trying to get my social security number from, you know, Nicaragua because he's gonna, you know, make us $1 million or something like that. Cybersecurity from a CAV perspective has multiple different entry points. You know, for years when we had CV discussions, everybody talked about the credential management system. And that's all anybody worried about is, well, you know, who's going to manage the credential management system? You know, we couldn't agree, oh, we don't want one company to do it, we don't want the government to do it, you know, we're worried about that. And that's all fine and dandy. We have to solve the credential management system, but it's one very small piece of the puzzle. And from a research agenda, that's where people have spent all the money doing research, is on the certificate management system. But there's a lot more of it that needs to be done out there. There's 4 different aspects of cybersecurity that you want to look at. Is, how are you going to get in, vulnerability, where do you come into? If you look at malware, and I'm going to talk a little bit about what you can do that. Malware is essentially putting software on that causes consequences differently than the original person affected the machine. How do you detect it? That's where we spend a lot of energy on, is how do you know something's gone bad? The part of cybersecurity, to me, that worries me is not when Target announces their database has been smashed. It's all that time before they knew it had gotten hacked. That's the time that cybersecurity is particularly scary. And then lastly, how do you defend against this and how do you respond it? And I think at the end of this presentation, if you understand the technical details, you're going to walk in here going, you can't do it. I think there's a significant amount of problems out there. One of the things that let's look at, how do cyber attacks occur? There's physical aspects, there's different kinds of buses. Again, we talk about DSRC and CV if you've just kind of been at the high level of the community. But how many people know what the CAN bus is? Anybody know what the CAN bus is? And that's the bus that all vehicles have, that all the different devices plug into. Well, the CAN bus has been around for a long time. And when the CAN bus was developed, the IBM PC didn't exist. Malware didn't exist. It was basically a very simple serial bus that allows devices to exchange information on a car. Now, the codes they use are highly proprietary to each vendor. So, knowing what a Ford code on the CAN bus is very different than what a Chrysler would be from a GM, from a Toyota, et cetera. But it is a common piece of wire, if you will, that connects all of these different devices on the vehicle. That's a huge penetration point, because when you think of CV, everybody's thinking of data coming into the car over the airways. What the CAN bus allows you to do is start from the car and then go out and do something. And that's the area where very little research has been done. We talk about cellular, Wi-Fi, Bluetooth. Most people know a lot about that. Then there's all kinds of software attacks. How many people in here know what fuzzing is? If you don't know what fuzzing is, you ought to go read up on what fuzzing can do to your car. Fuzzing is basically when you go after software, you look for anomalies. It's not a denial of service type attack. It's a little bit different, looking at how can you, though, take a piece of code that someone else has. And one of the things we do is people send us products, we latch onto it, and we basically start rebuilding what their software does, and you start looking for holes in it, because almost every software person puts some kind of backdoor in their software. If they're told not to, everybody tells them not to do it, it's there, it's real. Cars. I don't know how anybody ever heard of a Mustang. If you went back to 1965, there was no computers in there, and there was no software. That was a sweet running machine. I had one of these when I was in high school, and when you wanted to fix it, you opened the hood, you crawled in. Yes, I was a little more nimble back then, a little thinner, but you sat inside and you took a wrench and you put on different components, and you put 2 or 3, there's only half a dozen parts in there, wasn't that much to replace. It's a little bit different today. I'll actually challenge Doug's comments about 30 different computers. A lot of people now are talking that there's 150 to 200 computers on a car. How many people in here have a tire pressure monitoring system? That's 4 computers. Each one of those is wireless. You ever thought about someone to attack you from a TPMS system? What happens, you go to Discount Tire and they take your tire off and they go, oh, you need a new little $5 device. It's a little device, they put it in there. What if somebody put some malware on that device and started getting into your car that way? Some people go, oh, well, they're going to tell me my tire's low. No, that's not the point. The point is they get an entry into your system because that's being processed by other computers on the system. Bottom line is, if you look at the graphic over there, cars have a tremendous amount of software. Anybody know what's the most software on your car? Where's more lines of code than anywhere else in your car? Radio, infotainment system. Why? That's probably the most common upgrade that people will buy. You go try to sell a safety system, talk to my DOT friends, and you say, hey, for $500, this safety system will save your life. They'll kind of go, you say, but for $1,000, I'll give you a radio with 400 watts power. Cool, I'll take the radio, but I won't. That's real. You read the statistics of what sells out there. Infotainment systems are huge. There's tons of holes in infotainment systems. We actually have, I looked yesterday before I left, I drove up here, we have 17 different infotainment systems on our workbench right now. We have them from Maseratis down to very low-end cars, and they're just sitting there. They got all these leads in there, and they're hooking in. And the good news is we make a living. Keep buying them, keep doing it, because there's plenty of work for folks like us. So the real challenge, and I think the terms I want to leave here, because I think it's really, is Steve's talking about setting a research agenda and what we should do, is this whole concept of the systems of the systems. And some ways that it's kind of a trivial phrase or whatever, but that's truly what a vehicle is. A vehicle's got safety systems, it's got it's got non-critical systems, You have systems that are for control systems, and all those things play together in a car because they're all interfaced somehow. Those are not all independent systems. There's wires in between them. There's different ways to do it. And so in the challenge in the cybersecurity area, CV is one of these 200 systems, 150 systems that's coming into your car. What about all the rest of them? That's all tied into this whole concept of the CAD and what you're going to do. So the next challenge that I see is, we talk some about regulation, and I'll admit, I was the person who raised that question. I'm one of the most anti-regulation people you'll ever meet in your life, but I did raise the question because there's probably is some reality of it. A car does not come from one manufacturer. And I think people get misled about that sometimes because it says Toyota, it says GM, it says VW on there. Well, let me tell you, they have a whole bunch of tier 1 and tier 2 suppliers who all provide those parts. So the real question to you is, how can a manufacturer tell you that their car is cybersecurity? But they didn't even build it all. They built different components. Even more interesting, because we deployed a couple vehicles to Afghanistan, a couple automated vehicles. And one of the things the military did to us is they locked down configurations 6 months before we shipped. And we had a part break. They wouldn't let us repair the vehicle because they didn't know who the supplier was of that part. Where I'm going with that is on a car is in the middle of a production run, for June and July, you may be getting parts from tier 2 supplier company A, but then all of a sudden another company C comes up, gives them a better price, and they'll change out those components to something else. So you've got the reality, how many people have ever been in an accident? And you go in there and what do they want to do? They don't want to give you OEM parts, they want to give you a cheaper part, right? Well, where did that part come from? How does that violate the structure of your car? If you had a car that's been cybersecurity certified, and all of a sudden you put a component on to fix something that breaks. Just think about all the different ramifications of all that type of thing, if you don't mind. Again, CV's more than DSRC, I've already pointed on that. I love this picture. Thank you for showing it, Doug. This actually generated $2.4 million of business for my company. I'm not going to tell you from what company, but they really had a problem. And it's ironic how many car companies, it's actually stimulated, just like Google in some ways kickstarted the autonomous vehicle community. There's a number of people doing autonomous vehicles, but Google really brought it to the forefront and really put it on the front of everybody's market. Those two hackers did an amazing job for people in the cybersecurity industry because everybody got really concerned about it because of the potential significant consequences of it. Security, okay? You're selling cars. Do you try to make the absolute best car? I mean, why are there differences in cars? Why do some companies deliver cars that have fewer defects than the other? Could they all do the same job? Yeah, well, what's going to happen to the price? It's going to go up. Well, security, cybersecurity, it's a balance. You got to decide what you want to spend your money on. When we do our programs, we tell people there's three components to a project. There's cost, there's quality, and schedule. Which two do you want? And you think about that for me, yeah, it's cute, but there's some reality. Same thing with cyber, so you have to think about that. Here's a drawing. Most people in the ITS industry have seen things like this. One of my questions to you, just glance at that. How many cyber security points do you see in there? How many attack vectors do you see in that drawing? And just think about that. We're going to come back to that drawing a little bit later. Most people, if you've only been coming to high-level sessions for the last 10 years in the industry, you go, well, it's connected vehicle, because that's what that drawing's depicting is communication. They'll go, oh, it's only connected vehicles, the only entry point. So we'll come back to that. All kinds of touch points. Don't really need to go through this in tons of detail. I guess everybody in the room understands this, and you'll have the slides. So one of the challenges is, how do you test all of this stuff? And the thing that we're seeing right now is we don't have a lot of good techniques to test for cybersecurity. Some of it you don't know what you're testing for. In the software industry, it's very hard to test what you don't know. In other words, here's a set of requirements, and it's easy to test a product to say, does it meet these requirements? But how do you test it for what it doesn't do? In other words, the unintended consequences or the unintended requirements that are part of the system. It's a big issue in the software industry. All kinds of different challenges on it. Sensor data is a huge issue. Somebody asked me, well, what's the big deal with someone being able to hack your car on an automated car? What happens if someone goes in and hacks your inertial nav unit, or they hack your wheel sensor? Wheel sensor is a wheel encoder that measures how many times your wheel is going around. And you're in a connected vehicle environment, and you're exchanging BSMs, okay, your basic safety messages, and you've got an app that says, this vehicle's in my lane, I need to take an avoidance maneuver, or an emergency braking maneuver. Well, somebody goes and hacks the basic data into the car, and the car's really not doing anything, but the system starts saying, hey, you went into an emergency brake mode. In other words, you're just doing this as software. I'm not talking about it happening physically. You're basically making a false injection of data in there. You could then have other vehicles that are connected by CV totally reacting in a different way. You didn't hack the CV channel. You didn't, there's no issue that you hacked the other car. You didn't hack the CV. Your vehicle's now giving erroneous data. That's a big issue, okay? If you want to disrupt people's lives, I think Doug's the one that said that, there's lots of ways to disrupt with bad data. Sensors, this is a huge issue, especially in the auto industry. And again, it's one I don't want people to underplay when they think about how do you start making all this stuff work, is there's not one supplier, okay? There's multiple suppliers. It's a very cost-competitive industry. When you're building cars, you're always trying to find who's the most cost-effective supplier. Sometimes you go overseas. Sometimes you go to countries that you may not be so interested in. How many people in here use Lenovo computers? Okay, Lenovos are banned in half of our buildings. Because I don't know if you know, there was history that Lenovo in the firmware put a bunch of software, I shouldn't say Lenovo. Somebody put in Lenovo servers a bunch of firmware, was basically went harvesting corporate data and then transmitting it to a country that is across the Pacific Ocean, okay? In other words, people were buying Lenovo's very innocently, plugged them on their network, and all their file servers were just being sent overseas, okay? So supply is a big issue. So what do you do about all this? Let's put up an amazingly busy eye chart. I'm not going to try to talk through it. Does anybody recognize anything in there? The flying V, everybody kind of understands it out there. And so, we understand how to do, to some degree, we know how to do life cycle type development. Not that everybody follows it all the time. Well, there are some security standards out there. There's an ISO standard. There's a SAE standard. I encourage you to go out there and read them. I would do it at 8 o'clock at night after a couple of beers, and you plan to be bed at 8:30. It's amazingly dry stuff. I don't pretend to understand it. My cybersecurity guys claim that they do. But there's lots of things that you can do to try to build cyber into your systems. It's expensive to do, and unfortunately what happens is we've got how many years of automobile evolution? 120 years of automobile evolution that cybersecurity wasn't built into. And how are we right now, how are people like Google and Uber, how are they doing automated vehicles? They're taking existing platforms and retrofitting hardware onto them. They've not designed that vehicle from ground up trying to be safe from cybersecurity. Part of my point is that to get vehicles immune from cybersecurity, you're gonna have to go through design cycles, what's 5-year product cycles on cars, et cetera, and that's not a trivial amount of money. Because you know what, if you put on this sticker that, well, this car's been, there's a $5,000 option to have the cybersecurity on it, how many people are gonna buy that option? Probably most people in this room, because you're smart people, but a lot of people aren't gonna buy that option. They're gonna go buy the radio, or they're gonna buy the cool tires with the big mags and all that kind of stuff that looks good. They're not gonna buy those basic components. I put this drawing up. This is from Ford Motor Company. This is something Ford, when you talk to them, the head of their cybersecurity group, her name escapes me right now. I heard her last week, and I asked if I could borrow this slide, because these are all the different attack vectors that they're looking at on their current Ford products. And they're worried about from the bottom, those are the basic sensors in there, all the various networks, the LTE networks that they have on some of their cars, their various wireless, their Bluetooth. When you put your phone on, people are worried about, can you penetrate in from Bluetooth into the device to do something? The point is, they spend a lot of money doing this. So, in getting here to the end, I put this graph up here, and so now I augment it. And so if you're a state DOT guy and you're thinking about putting connected vehicle out here, I want to throw out to you, there's a lot of places to look for cybersecurity in your system when you put it out there. Cyber between vehicles, just the roadside unit to the onboard unit is one aspect, but you got to look at all the other different injection points as you go through your system, and that's really not all. And I think there's 9 listed on there, starting from the vehicle and going around, but there's a lot of different issues on that. And with that, I stated my time. infotainment system, which is what most passengers probably have the greatest